Welcome back, guys. Today we're going to be looking at topic 6.3, which is solving problems with more than one triangle. Now, when we get into this lesson, the concepts of trigonometry have not changed. The only difference between these lessons and previous lessons is that the word problems are going to involve questions that have more than one triangle. So these are all going to be multi-step problems. Now, as we work through these, I'm going to try to show you a variety of examples that you might come across and try to give you some tips and tricks along the way. As we're working through these examples, you may want to have your notes nearby or a sheet of loose leaf. I would suggest that you try reading through the question, maybe even trying to draw the diagrams yourself if you can, and then working through the problems, pausing the video along the way. All right, so let's take a look at the first question here. So the question says that while on vacation, a couple decides to climb a cliff overlooking a river. Now they're planning ahead for their climb, and so they decide to hire a surveyor to take some measurements to calculate the height of the cliff. Now this question already has the diagram drawn, and I'll give you a little hint. You're going to see this picture a few more times, probably on tests or quizzes, maybe even a final exam. Numbers will change, but this diagram I use a fair bit. So from a point P on the shore, directly across from the river, the angle of elevation to the top of the cliff is angle RPT, and that's 43 degrees. So there's our point across from the river, that's point P, and we have our angle of 43 degrees. Now it says from a point S, 30 meters down the river, so 30 meters down from point P, we have another angle that's angle TSP, and that's 68 degrees. Now, sometimes when these diagrams are being drawn in 3 dimensions, it might not actually look like a true 68 or a true 43. So don't assume that these diagrams are drawn to scale. Now, the first question says, using this information, what is the height of the cliff? So our ultimate goal is to find the height of the cliff. Now, when we have two triangle problems, our biggest obstacle is figuring out what we have, what we need, and what we're going to do to get there. So often when we have two triangle problems, there is a shared line between our triangles. And so if you notice, we have this yellow triangle and we have the blue triangle, and that yellow line is the shared line. And so quite often we're going to be finding the shared line and using that shared line to find our missing information. Also, when we're doing these questions, there's quite often times when we have to relabel our sides. For example, when we look at 68 degrees here, we look across the triangle. I'm going to label this as my x. X is going to be opposite, and 30 would be adjacent. But later on, when I have to use angle 43 degrees, X will now become adjacent. And so we just have to consider relabeling our triangle. Sometimes it helps to have a second color pen. I often will actually draw the triangle separately in my workspace. All right, so ultimately I'm looking for the height h. Now if I look at that triangle, the yellow triangle, I need h. I have 43 degrees. I don't have anything else. And when I'm solving a trig problem, I need at least two sides and an angle, and I can only have one unknown. So I'm going to have to find something else. Now, finding the hypotenuse, first of all, I don't have enough information to find the hypotenuse straight away. So that's probably not going to help me. But I can find this shared line. So that's my x value, and I can use the blue triangle to find that x. So that's going to be my first step. All right, so I'm actually going to redraw the triangle here. You can also label it on your diagram. So using this 68 degrees, labeling my sides, x is going to be opposite, and 30 degrees is going to be adjacent. Again, I'm just going to relabel my triangle over here. I am looking for, oh, that's not quite the right triangle. Let's try that again. So labeling my triangle here, or drawing my triangle, I have my 90 degrees over here. I have 68 degrees, I know. I'm looking for x, so I'm not drawing it necessarily in the same orientation, but everything's going to be in the correct position. And I have 30 meters down here. So looking across the triangle, I have x is opposite and 30 is adjacent. Using my trig ratios, opposite and adjacent is tangent. So setting up my ratio here, I'm going to have tan of 68 degrees is opposite, which is x, over 30 meters. Now solving to get x by itself, I'm going to multiply both sides by 30, which will give me x equals 30 times tan 68. Now, as we work through these problems today, I'm going to be pulling up the calculator because I want to show you how to keep your answers from being rounded until the end. And so we're going to talk about that here shortly. So again, when you're using your calculator, you want to make sure that your calculator is in degree mode. So click on your mode button, make sure your calculator is in degree mode. Second, quit. And then we can go 30 times tan 68. And that will give us 74.25, rounding to the nearest tenth, 74.3 meters. All right, so now we know that this length right here is 74.3 meters. I'm actually going to erase my labeling. I'm going to put in that 74.3, and I'm going to relabel my triangle. So 43 degrees is now the angle I'm going to use. Across the triangle, height is what I need. That's my opposite. And 74.3 is my adjacent. So again, I'm going to redraw my triangle just to show that labeling. You don't have to redraw. You can absolutely use the diagram as it's given to you. Sometimes it's just good practice to redraw things out, and sometimes drawing it out gives you that visual that you need in terms of what we're solving for. Sometimes when triangles are oriented in 3 dimensions, it's difficult to see everywhere you need to go. So we have 43 degrees, H is our opposite, and 74.3 is adjacent. So again, we're going to be using tangent. So tan of 43 degrees is opposite, which is H, over adjacent, which is 74.3. Now to get H by itself, we're going to multiply by 74.3 on both sides. So we have tan 43 times 74.3. Now we've rounded our answer on paper. So we've rounded it to 74.3. But when we're doing trig problems or any time that we're doing multi-step problems, it's important that we keep our answers exact on our calculator. So we can round on paper, that's fine. I don't expect you to write out all those decimals. But on our calculator, we need to keep the numbers exact. Otherwise, we can get multiple rounding errors. And the more calculations you do, the more you round along the way, the more rounding errors we would have. So on our calculators, we'll keep it exact. Now with a TI-84 calculator, this is quite easy to do because you can arrow up, choose the answer you want, arrow back down. With the TI-83 pluses, we can recall answers, and I'll show you how to do that when we need to. Often though, sometimes it's easier just to write out a few decimals. So even writing out 4 or 5 decimals and entering them in is fine. We can use a store feature in our calculator, but often it's quicker just to write out the decimals. All right, now for this question here, we're going 74.3 times tan 43. So I'm just taking that number and multiplying by tan 43. So I'm just going to hit the times button. It'll bring my answer forward and then type tan 43. And so that gives me an answer of 69.2. So again, I went H equals H equals 74.3 times tan of 43. And that gave me a height of 69.2. Now, in this case, that is my final answer. That's what I'm being asked for, is that height. Sometimes, depending on the diagram, this answer only gets us part of the way, and then we have to either calculate another step further or add numbers together. Everything depends on what the question's asking us. Now, second question here says, if a zip line was built from the top of the cliff to point P, what would be its slope? So if I were to build a zip line, let's say we climb to the top and now we want to take a zip line down. We want to figure out the slope of that line. Well, remember from our previous unit, M is slope and slope is rise over run. So if slope is rise over run, that's going to be our height divided by our horizontal distance. So M is going to be 69.2. 0.2 meters divided by 74.3 meters. And we'll put that into our calculator. Now I'll show you the difference here. Sometimes rounding doesn't make a difference. So for example, here 69.2 divided by 74.3. If I were to take 69.2 0.2416741 and divide by 74.2526056. In this case, the rounding error wasn't significant enough to cause me to have to change my answer. But if you notice, we've got 0.931 versus 0.9325. So even there is a bit of a rounding error. Because we're only rounding to the nearest hundredth, it didn't make a difference. But again, if we can keep our answers exact, all the better. And then remember that slope has no units when we're not dealing with rate of change in terms of line graphs. So the meters cancel each other out, so the slope is just 0.93. All right, so this is one example of two triangle problems where we have a shared line. So quite often, if you're trying to find a missing dimension and it's a two triangle problem, often we start by finding what that shared line is. All right, let's take a look at another question here. So this question says that we're determining building heights. And so the question says that a building is 32 meters tall. At one position from the base of a building, the angle of elevation to the top of the building is 81 degrees. Now, if you remember, when we're talking about angle of elevation, that's looking up from the horizontal. So we're going to have a 32-meter building, and at some point, we're going to look up to the building. That angle of elevation from the horizontal is our 81 degrees. Then it says at a position 4 meters further away, what is the angle of elevation? So that means we're going to walk further away and look up to the building, and now we're looking for that angle of elevation. So I'll show you the diagram here. This would be a question where you'd be expected to draw your diagram. Looks like the erasing isn't working, so I will just draw it out. So we're going to have our diagram. We're going to have our building. Now, looking up from a certain point here, we're going to have. We've got our horizontal line here. From a certain point, we're going to look up to the top of the building, and that distance is going to, or that angle is going to be 81 degrees. And then walking 4 meters away, we're also going to look up to the top of that building. We're trying to find that angle. So we've got our building. We know that the building is 32 meters tall. We know that our angle of elevation looking up to the top of the building is 81 degrees. We have our 90 degrees here. We know that if we walk 4 meters away, we're going to have another point, and we're looking for that angle of elevation. Now, let's take a look at what we have, what we know, and what we're looking for. We know the height of the building. We know that this triangle here has 81 degrees. We know there's another triangle that has an angle of x, and we know that the distance between the endpoints of these two triangles is 4 meters. We do not know what this amount here is. Now, this is an example of what we can call nested triangles. So essentially we have two triangles and one is hidden within the other. When we have nested triangles, it's often a good idea to redraw your triangles. So we have one triangle here that has a height of 32 meters, has an angle of 81 degrees, and we don't know what the horizontal length is. We have another triangle that also has a height of 32 meters. So this is another example of something with a shared line. It's just a little harder to recognize because one triangle is nested within the other one. Our unknown is x, and we do know that y plus 4 is our horizontal length. So to find what we need, to find this angle of elevation, we're going to have to use the 32 and the 4 plus y. We don't know what y is, so we're going to go to the first triangle and use the 32, the 81, and the y, find y, then we can use that y, add it to the 4, and then we can find our x. So let's break it down step by step. All right, so first step, we're going to work with that triangle that has the 81 degrees and the 32 meters. So we've got 32 meters, 90 degrees, 81 degrees. Again, your triangles do not have to be to scale. It's just important that you understand where your opposite and adjacents are. So labeling our triangle here, 32 is opposite, y is adjacent, so we're using tangent. So tan of 81 degrees is opposite, which is 32, divided by y. And so to get y by itself, we're going to take 32 and divide by tan 81. So y is going to be 32 divided by tan 81. Again, doing that on our calculator, we have 32 divided by tan 81 gives us 5.06, or that rounds to 5.1 meters. Again, if you've got a T83 plus, you can certainly write out the decimals a little bit longer. I'm still going to just round it here to 5.1 meters. All right, now once we have that, we can use that 5.1 to finish off our other triangle. So again, this triangle here had 32 meters. We are trying to find what this unknown is here, but our measurement down here was 4 plus y. Well, 4 plus 5.1 means that this length here is 9.1 meters. Now, finding the angle means that we're going to be looking at opposite and adjacent. And when we're looking for the angle, we use the inverse. So the angle is going to be tan -1 of 32 over 9.1. So let's take a look at that on our calculator. First of all, we have this 5.06. We're going to add 4 to that. So again, we've kept it exact on our calculator. Then we're going to go second function tan. Now, if I want to pull that answer forward on a TI-84 plus, I can just arrow up, hit enter, it'll bring the number down. On a TI-83 plus, I have to push second function answer, so second function negative. It's going to bring that number down, except I actually don't want that yet. I want the 32 first. So tan -1 of 32 divided by second function negative, meaning it pulls my answer down. And then we hit enter, and that gives us 74 degrees. So our angles, we always measure to the nearest degree. All right, now these nested triangles tend to be the ones that cause the most difficulty because we have to kind of look. It's almost like a little puzzle looking for those hidden triangles. So if you need some more practice, just go back and review this question a couple times over. All right, another example here. This one is titled Cabins on the River. So we have this diagram, and sometimes when you see the diagram, instead of going straight to the question, just ask yourself, what kinds of information can I find? In this case, there's already an X labeled, so we're probably going to be looking for the width of the river. But using the 15 and the 420, I can find this side length here. I don't know, let's call it Y, or maybe A. I could use the 420 and the 15 to find the X value. I can also, once I know that X value, use the 70 and the X to find this hypotenuse here. And if I knew the X, I could also use the 70 and the X to find this value here. So ultimately, I can find all of the measurements I need. So I could ask you for the distance between the two cabins. I could ask you for the perimeter of the triangle. I could ask you for the width of the river. So one diagram can actually lead to a multitude of questions. Whenever possible, I try to use the measurements that are given to me. Sometimes we can use a calculated measurement or the one given to us. If I have a choice, I'm always going to choose the ones that are given to me because I have less chance of making a mistake. All right. So starting with the first question, we're being asked for the width of the river. So again, I'm going to redraw my triangle. Deciding which side to draw on, I have to look at what information I'm given. The left triangle, I know 15 degrees and 420. So that would give me enough to solve the triangle. On the other side, I have just the 70 degrees and everything else is unknown. So I'm going to start with the left triangle. So labeling my triangle here, I have my 90 degrees. I'm looking for X. I know 15 degrees and I know 420 meters. So labeling my triangle, X is opposite and 420 is hypotenuse. So using my trig formulas, opposite and hypotenuse is sine. So sine of 15 degrees is X over 420. Solving, I'm going to multiply both sides by 420. So I'm going to have X equals 420 times sine 15. Notice all the way along the way, I'm trying to remember to use my degree symbol. All right, so I'm going to have 420 times sine of 15. And that gives me 108.7 meters. Again, I'm rounding on paper, but if I need this question again, or need this number again, I will use the exact one in my calculator. All right, so the next question asks me, what is the distance between A and C? So A and C are my cabins. So I'm really looking for the distance between the two cabins. So I'm going to label this as, because normally I could label it across and say B. I guess I could call this B1 and B2. I'm just going to label this Y and Z. Okay. It doesn't really matter when we're solving here. Convention would say to label these as B1 and B2, but I'm not too worried about that at this point. All right, so redrawing the triangles here. My first triangle here has 15 degrees and 420 meters, and we now know that this side is 108.7 meters. The other triangle, we know 70 degrees. We know that this side is 108.7, so notice that's the shared line. And for this triangle, we're looking for Y, and for this triangle, we're looking for Z. Now, if we want to know the distance between those two cabins, we're going to have to find the values Y and Z, and then we're going to add them together. All right, so again, as we're doing these two triangle problems, start with the question, look for what you know, and then work backwards to figure out what you need to do. All right, so first question here, we have 15 degrees. I'm going to, again, I have the option of using the 420 or the 108.7. I'm going to use the one that I'm given. Again, for one, less chance of rounding errors, and for two, less chance of calc errors because I'm using something that I've already been given. So I'm going to use the Y in the 15. So Y is adjacent and 420 is hypotenuse. So using my trig ratios, that gives me cosine of 15 degrees equals Y over 420. Solving, I have 420 times cos of 15. And so putting that into my calculator, I have 420 times cos of 15, which gives me 405.7 meters. So that's one of the distances. Now I'm going to look at the other triangle here. I have 70 degrees. This side is adjacent, and this side is opposite. Now in this question, I have no choice but to use that calculated value. So I'm going to have opposite and adjacent. I'm going to have tan of 70 degrees equals opposite, which is 108.7, divided by Z. To get Z by itself, I'm going to have 108.7 divided by tan of 70. Now again, if you have a TI-84 Plus, you can easily just scroll up and find the answer that you need. I'm going to have to redo the calculation here because I cleared my calculator. So I'm going to have 420 times sine 15 gave me that 108.7. Now I'm going to take that number and divide by tan 70. If I had already had other calculations and hadn't cleared it, I could easily type in that number. And again, with the newer calculators, you can just scroll up. So that gives me 39.6 meters. Now, once I have those two amounts, all I need to do is add them together. So 405.7 plus 39.6 gives me a total. Again, on my calculator, I'm going to keep those answers exact. So I'm going to have to just type that one in one more time here. So 405.68847. So that's going to be added to the 39.56501,996. Again, newer calculators, just scroll up. So rounding that off, we have 445.3. Now, if you really want to keep everything exact and not have to worry about typing anything out in terms of numbers, you could also type this all in one step. So you could go in brackets 420 times cos 15, close your brackets, plus that 108.7. I guess that part we'd have to type out, but we could go that 108.7 and so on, divided by the tan 70 and get our answer. So if you wanted to keep everything exact, you could type the entire trig functions out, but it's a lot of brackets and everything else to worry about, and just as many chances for errors. So again, our final answer here is 445.3. All right, let's look at a question with angles here. So this question is entitled Roofing Angles. And so the question says that a non-standard roof on a house has one side that is 18 meters long, the other side is 23 meters long, and the peak is 14 meters high. So using this information, the first question we're asked is to find the angle formed at the peak. Well, this is our peak right here. And so in order to find that angle, we need to break it into two pieces. Now, next year when you guys get into Math 20, this is a non-right triangle, and non-right triangles you will learn how to solve next year using the sine law and the cosine law, but this year we're doing everything with SOHCAHTOA. All right, so first we have to find out the x angle. So on my diagram up here, I can label my opposite and adjacent. So I have my x angle here, and so this side would be adjacent, and 18 would be hypotenuse. For the y angle, 14 is still going to be adjacent, and 23 is going to be hypotenuse. So in both cases, I'm going to be using cosine. So for the x degree, cosine -1 of adjacent over hypotenuse, so 14 over 18. And for my y angle, it's going to be cosine -1 of 14 over 23. So let's put those into our calculator. We have second cos of 14 divided by 18 gives us 39 degrees. And then second cos of 14 divided by 23 gives us 52.5 degrees, so that would round to 53 degrees. Now we want to know the total angle at that peak, so I'm basically adding these two numbers together. So I'll hit plus 38.942 gives me 91 degrees. Now, if I had used my rounded values, of 39 degrees plus 53 degrees, notice I would have got 92. So this is an example where rounding early and then using those rounded values would lead to a wrong answer. This was a numerical response question. 92 would be marked wrong, 91 would be marked correct. So again, we have our x value here. Our x degree was 39 degrees, and our y degree was 53 degrees. Adding those together, we get 91 degrees. So the total is 91 degrees. And if you want to make a note for yourself, this is an exact value. So that means we did not round on our calculator. All right, now the next question asks for the span of the roof. Because our diagram is up higher, I'm just going to redraw it here. We know that we have 14 here. I know there's measurements. I'm not worried about the measurements right now. We have 14, 18, and 23. We're being asked for the span of the roof. So we're being asked for this distance here. And so ultimately we need to know the distance between those 2 points. So I'm going to use A and I'm going to use B. So because we get so into using trig formulas all the time, we forget sometimes that we can just go back to Pythagorean theorem. If I want to know the span of the roof, I just need to know these two sides. And if I have two sides, the third side can be found using Pythagorean theorem. So A is going to be the square root of 18 squared minus 14 squared. So side A is going to give me 11.3 meters. Again, I'm keeping it exact on my calculator. And B would be 23 squared minus 14 squared, which gives me 18.2 meters. And the span of the roof would be the total of those two numbers. So the span of the roof would be 30.0 meters. So let's see why that is. Again, rounding is important as we're working through all of this. So second function, 18 squared minus 14 squared gives us 11.3. And then second root 23 squared minus 14 squared gives us that 18.248. So we add those together, 11.313, and we get 29.56. Well, if I'm rounding to the nearest tenth, I look at the 5. Looking behind the 5, I have a 6. So the 6 is going to round up the 5 is going to round up the 9, and that's how I'm getting 30.0 meters. Again, if you need any help with rounding, just ask me and I will help you through it. All right, so now it's your turn. I've got 3 questions here, and these are also in your notes. I want you to pick any 2 questions, try them on your own, and then come back. I'm going to talk you through all 3 here, so certainly if you want to try all 3, go for it. All right, in all cases, the diagrams have been drawn for you. And if you remember, we actually did some of these problems in a previous lesson where I gave you the word problem and you just had to draw the diagram. Now we're actually going to go through and do the solving of those. All right, so the first question here says that a cell phone tower is supported by 2 guy wires, and the guy wires again are just support wires, each attached to the ground 3 meters from the base of the tower. And so each wire is attached 3 meters from the base of the tower. Now the angles of elevation for each wire are 46 degrees and 34 degrees. And the question is, how much higher up the cell phone tower is the top guy wire attached? So really we're asking for the difference in these 2 heights. All right, and that's labeled there. Now, in order to do that, I have to figure out how high up the pole each guy wire goes. This one is not an example of finding a shared line so much as finding the difference between the 2 points on the pole. So I'm going to redraw my diagrams here, just so it's easier for labeling. I have 46 degrees. This is 3 meters away, and I'm looking for this height. And then I have another triangle that is also 3 meters away. I'm looking for this height, and I know the angle is 34 degrees. So labeling my triangles, A is opposite, B is adjacent, B is opposite, and 3 is adjacent. Now, I think I mentioned in a previous video, it's quite common for us to see tan show up quite a bit during these 2 triangle problems. Don't read anything into it, it just happens the way it happens. All right, so we've got tan 46 here equals A over 3. Multiplying 3 times tan 46, A is going to give us 3.1 meters. And then for the second question here, we have tan of 34 is opposite, which is B over 3. Again, multiplying, we're going to multiply by 3 on both sides. I can label that over here as well. And we have 3 times tan 34 gives me B is equal to 2.0 meters. Again, you're going to keep these exact on your calculator, but we want to know the difference in the heights. So we know that this height here, this pole or the guy wire with the 46 degrees reaches 3.1 meters up the pole. We know that this one reaches 2.0 meters up the pole. So the difference between those, 3.1 meters minus 2.0 meters, is 1.1 meters. And again, I would have kept those numbers exact in my calculator. All right, example number 2. This is a very common question as well, and one that can often lead to some common mistakes, which I'll point out when we get further in. So the question says, from the top of a 350-meter building, the angle of elevation to the top of another building is 60 degrees. So we have, sorry, my diagram doesn't match, so I'm going to change the numbers in here. So from the top of a 350 meter tall building, the angle of elevation to the top of the other building is 52 degrees. So just a little typo there. 52 degrees. The angle of depression to the bottom of the second building is 60 degrees. And the question is, how tall is the building? So here we have it labeled as an X. You can use an H, it doesn't matter. So we're going to take this diagram and we're going to add some extra information. So we have 350 here is the height of the building. And so if this height here is 350, that means this height here is also 350. And so sometimes just by relabeling that helps us give a visual. Ultimately, we need to know the height of the building. So we need to know this measurement here and we've got the 350 already. So we need to know what this measurement is here so we can add them together. Well, if we look at our top triangle, we don't have enough information. We know the 52 degrees, but we're missing a side length. So this is another example where we're going to be using our shared line. And so we're going to start off by labeling this here. Again, you can use A or X or whatever you need. This 60 degrees and the 350 can be used to find A. All right, so we're going to start off with the 60 degrees and the 350, labeling our triangle. 350 is opposite and A is adjacent. So we're going to be using tan. So tan of 60 degrees is opposite, which is 350, all over A. Solving this, we're going to have 350 divided by 60. So A is going to equal 350 meters divided by tan of 60 degrees. And that gives us 202.1 meters. Now we're going to use that amount for the next question. So if I wanted to redraw that triangle, let's redraw it over here. I now know that this side here is 202.1. Again, that's a rounded value in my calculator, so I'll type that in here shortly. I know this is 52 degrees, and I'm looking for this value here, so we'll call that B. Labeling my triangle, I again have opposite and adjacent. So setting up my ratio, I'm going to have tan of 52 degrees equals opposite, which is B, over adjacent, which is that 202.1. Getting B by itself, I'm going to take that 202.1 and multiply by tan 52, and we'll see what answer we get with our calculator. So I'll type in that first step so we have that included. So for the first step, we had 350 divided by tan 60. And that gave us our 202.1. And we're going to take that number and multiply by tan 52. And that gives us 258. Sorry, let's try that again. So yeah, that gives us 258.6. Now, at this point is often where a common mistake happens. We start working with these numbers and we have times where we just have to add these two numbers together. And so there's a common mistake where people just go, oh, I got my two numbers, let's add them together, I'm done. But we always have to look at what the calculated values are. This 202.1 here is the distance across the buildings. I want to know the height of the total building. So this here is 350 and this here is 258.6. So it's these two numbers that I'm going to add together. I'm going to take the 258.6 and I'm going to add the 350. So add 350 and I get 608.6. So again, we don't want to just add random numbers together. We want to make sure that they make sense in the context of the question. So the 258.6 plus 350, our height again is 608.6 meters. Okay, quite often I see students that will take and add the 258 and the 202, which means we're adding the width of the building plus the height of the building. That won't give us the height of the bigger building. All right, moving on, we've got our third example here. This again is an example of those nested triangles. And the question says a person is standing 275 feet from the base of a building. The angle of elevation to the base of the tower's antenna is 32 degrees, and the angle of elevation to the top of the antenna is 42 degrees. And the question is, how tall is the antenna? So very similar to the guy wires question, but just a different diagram. The only difference between these is that on the other diagram we had our triangles on opposite sides of the pole, and here they're on the same side of the pole. So sometimes this one looks a little bit more complex when really it's fairly much the same. Anytime we're dealing with nested triangles, sometimes it's helpful to redraw our triangles using the angles. So redraw our triangles separately. So we have 42 degrees. We know that this distance is 275. And we know that we have to find this height. And then the other triangle has an angle of 32 degrees. We also need to know that height, and the distance from the building is also 275. So labeling our triangles, we have opposite and adjacent. And labeling our other triangle, we also have opposite and adjacent. So setting up our ratios here, we have tan of 42 degrees equals x over 275. And this one will be tan of 32 degrees is opposite over 275. Again, we can put these into our calculator. We've got 275 tan 42 gives us 247.6. And then we have 275 times tan of 32 gives us 171.8. So x is 247.6 and y is 171.8 feet. Now, we're being asked for the height of the antenna. Well, we know that one line of sight reaches up to 247.6, and we know that the other line of sight totals or reaches 171.8. So ultimately, we're looking for the difference between those values. So on our calculator, we're going to take that 247 and subtract our other answer. So again, we can pull that answer forward, second function answer, and we get a distance of 75.8. So our difference, or our height actually, the height of the antenna our antenna is 247.6 minus 171.8 gives us 75.8 feet. All right, so that's quite a few examples that I've given to you. Hopefully that gives you enough of a variety. I am going to leave you with one little extra challenge, and I'm not actually going to give you the answer in the video. I'll give you what the answer is, but I'm not going to give you the work to get there. But I'm going to leave you with a little bit of a challenge here. I've actually pulled this from a math textbook. And so the question says building a fence. A rancher who lives near 100 Mile House, and I'm going to just change my view settings here so you can see the entire diagram. A rancher who lives near 100 Mile House, BC, is planning to build a new fence around his property using 3 strands of barbed wire. Now, using this information and the diagram of his property, how much wire will he need for the fence? And so I'm going to add in a little bit more detail here. So we have the 60 degrees and the 40 degrees. We need to know the perimeter of this fence, and there is one more piece of information that's not written in here, and that's the 200 meters right here. We need to know that that's also 200 meters. So we have a 200 meters, 500 meters. Our unknowns are the B and the A, and we can use those to figure out the perimeter of our fence, and then we know that he needs 3 strands of barbed wire. So the question is, how much wire does he need for the fence? Now, the answer to this question is about 4.4 kilometers of wire, or 4,432.9 meters. Now, that's without rounding. But the challenge for you is to figure out how I got that answer. And so I'd like to see what you can come up with. Feel free to send it to me. And if I had a Jolly Rancher, I'd send it your way. All right, hopefully that gives you enough examples, guys. I will see you soon.